are 4 gauge bosons, the photon, the gluon, W, and the Z bosons. Let's back up a step though. Starting with the photon, the force carrier of the electromagnetic force, it interacts through any non-neutral fermions, basically not neutrinos. But in the realm of quantum electrodynamics, or is it quantum field theory, I can't tell the difference, we think of it as a quantum field that carries the electromagnetic force. So basically, particles bashing together will go apart. And my animated particles, I'm using the radius of it to represent the radius that its field interacts through the electromagnetic interaction. But then physicist Richard Feynman effectively said, for the love of quantum electrodynamics, why couldn't we just view it as if there were a virtual photon in between the two? That works out great. Oh, and by the way, Richard Feynman also came up with the idea of a Feynman diagram. This one just shows 2 quarks coming together, one emitting the photon, and the other one absorbing it, and they move apart. Basically, 2 particles bashing together will bash apart. It's important to keep in mind, though, that we're talking about virtual photons. Virtual particle. That's what differentiates it from the particle of light that we also call a photon. Because, well, it's like a virtual photon, except it's kind of real. And it's just a kind of light that comes out of your flashlight or laser or whatever. Side note about the symbol, though, it looks like a fish. The gluon is the force carrier of the strong force. The strong force holds the quarks together. Notice the coloring. Now, there are 3 colors of quarks, red, green, and blue, as you can see, and this is just carrying the color charge. It's weird because it's a kind of charge because they aren't actually colored, but just like electric charge is associated with electromagnetism, color charge is associated with the strong force. I'll make an entire video on the weak interaction, that is, the force that the W and Z bosons carry. For now, I'll just say it's responsible for beta decay, which is when an isotope, like carbon-14, decays by emitting a W boson, which decays into an electron and an antineutrino. So anyway, I'll be back in 2 weeks after a video about probably higher dimensional polytopes, and I'll see you there.